Thank you for giving us the opportunity to present our work. We will be presenting Public Health Automated Case Event Reporting Platform for Sexually Transmitted Infections using FHIR. This project is funded by CDC, and we are currently doing our third phase. STI cases make up the majority of reportable conditions, but current state ECR has its drawbacks as follows. Retrieving patient health information is labor-intensive. Data formats are often different. Timing of reporting and clinical data may not be consistent. Information that needs to be captured may not be properly communicated. Electronic lab report can provide the accurate timing and condition, but the ERR contains just test results and is missing the clinical information. So our goal of this project was to build a platform using FHIR that can retrieve reportable conditions in a timely manner. The architecture was designed so that automatic case reporting can be augmented and reporting queries can be reconfigured based on the case while the privacy control is intact. Now I'm turning over to Michael to talk about the FHIR architecture and some of its key functionality.
Thank you, Myung. This is our FHIR architecture diagram here. You can see it has two major components. It has a green FHIR client server over here in the health department, and on the right side it has a blue FHIR server in the provider network. The FHIR client itself is mainly dealing with handling the case reports for the actual health department. And when a new case report is created via a lab message coming in, we create an ECR request to a FHIR server on the blue side. From there, mainly the CQL engine deals with talking to the FHIR server directly. CQL is a measures standards program that we use to keep track exactly about what we're querying to the FHIR server. We expect these standards, as you can see in the bottom left, to be generated from CSDE or CDC, who will create new archetypal CQL, and then that will be fed over to an eventual FHIR server if that ever needs to get updated over time. So we use CQL, or Clinical Quality Language Scripts, as our recipe book definition for what to query out of the FHIR server. So Clinical Quality Language Scripts, it's a high-level domain language for working with measure resources. In this case, we have a FHIR component as a happy FHIR connection directly to a FHIR server. And so I posted a snippet here on the right. You can see we're querying for things like patient, condition for any codes within a specific code set we've defined above of chlamydia codes. And so the CQL allows you to make any sort of code set definition you want, but also you can use a value set, an OID value set. And in the case of a generic standard value set, we can actually use FHIR here with its value set resource expand operation, where you pass in the value set and you'll get back the actual code set definitions afterwards. So we can do that at runtime when we actually parse through the script and expand off of those definitions. There's a small problem with global definitions, which is just that not every FHIR server in the world is going to use the same definitions for everything. And in fact, sometimes FHIR servers have their own code set definitions, or they create their own value sets for their own systems. Maybe the EHR initially was coded with those value sets. Maybe they're importing value sets from external systems. There are a lot of reasons why you might have a custom code set. But that's okay. In our FHIR server definition, we actually provide you a standard FHIR service that does a local code mapping system. We use the code mapping translate operation here to a little local FHIR instance inside, and the health provider themselves can actually load a little CSV file describing the source codes and what they go to in the target system. And so if we know what the CQL standard definitions will be, we can get the provider to provide a mapping file here. We can always do a translation at runtime from the source definition in the CQL to what the target code would be in the CQL server. So this can be easily integrated into any system without any existing translation service, because we provide that service within FHIR server itself.
Thank you, Michael. As FHIR is being more adopted, privacy is becoming providers' concern as they do not want some of the clinical data to leave their network. Thus, the privacy control is becoming one of the key features when accessing the data for reporting. In Pacer, to fulfill this need, we have developed a quick and simple file filter that can redact resources and or their data elements. Provider can configure the file filter and indicate what resources and or data elements should not leave the network of providers. The filters can be configured with JSON using provider's FHIR data structure. Thus, the FHIR filter supports any version of FHIR as long as the filters and the actual FHIR data are in the same version. As discussed earlier, the ERR provides somewhat accurate timing of cases. This allows the ERR becoming a good triggering message. When ERR is received at the public health department, initial ECR is created. Because the initial ECR is created from the first ERR message, it only has the information available in ERR. Thus, once the initial ECR is created, the Pacer client sends a request to Pacer server for clinical information about this case. The Pacer endpoint can be obtained from the Pacer index service, where the endpoints are managed with the provider information in the lab orders. Response to that request is an ECR that can be used to augment and enhance the initial ECR. In the first phase, we worked with Regenstrief HIE for an integration testing. And in the second phase, we worked with the Medical University of South Carolina to deploy Pacer platform and run for ECR results. With 8 weeks of lab data, 117 patients were identified as STI patients. We were able to capture diagnosis for 65% of patient, medication for 73% of the patient, and symptoms 71%, and for some demographics, we were able to get 99% of the patients. ERR itself cannot obtain these kind of information, but with the Pacer, we were able to obtain these clinical information and augment the initial ECR. I'm now turning back to Michael to talk about some additional information and conclude our presentation.
So we are a public institution at Georgia Tech Research Institute, and we're working with public health entities. So a lot of the times we try and make sure as much as we can to make our work available and for other people to reuse and use from there. So we license our stuff under the Apache open source license. We put most of our stuff in the public GitHub repository for the GT Health organization. The Pacer endpoint is for the Pacer server. There's a Pacer client, it's separated separately from the Pacer server, and there's also the FHIR filter from there. So I recommend, if you're interested in this stuff, we document things and put wiki information for all of these components up there. And we answer any issues, of course, that come up from there. So we're happy to take questions about the GitHub resources from that. So go ahead and take a look if you guys are interested, and let me know later.